So yes, we are live now. So hey folks, this is me Vishwas Nair. I'm the host of this BuildPiper show, and over a course of time, I've realized that there is a lot of complexity which is coming up in the market. Like you talk in terms of the YAMLs and the manifests which are supposed to be maintained. There is a lot of glitch that goes beyond because YAML is some sort of a glitch in your entire infrastructure. Like anything can go wrong, and in if you talk in terms of the Kubernetes is an infrastructure scaling platform, and you might talk anything about it, but from BuildPiper, we are having that humble attempt to make sure that everything that you deliver using BuildPiper is not in terms of a pipeline, it's a microservice. Because microservice is one of the first class citizen in our product. And hopefully you guys learn a lot. Hopefully you guys get to learn a lot about Kubernetes. And I think today's demo is basically going through the BuildPiper itself. So there is going to be a lot of insights that you can learn, and also there is a SaaS platform that is going to be demoed today. So do check it out. The links will obviously be given to you in the description, as well as you can reach out to us personally and reach out to us at connect@buildpepper.io, and let's get it started. So hey Deepak, thank you so much for giving this
Hey
show.
Vishwas,
It means a lot.
thanks. Pleasure all mine, and thanks to you, Vishwas, that you such a great host hosting these tech talks continuously, day by day, forthcoming days, right? And which is giving a platform to the community and back to the people, where they can explore and learn about more and tools and technologies, right? So thanks to you.
Yeah.
Yeah.
So yeah, let's get that first question. I always wanted to get this question. I didn't ask him till now. We were
Mhm.
backstage. We didn't ask anything. So, what was your journey as a professional? Like, how did it start? And once you entered the professional one, when was the first time that you heard the word called as Kubernetes? Like, what was your reaction at that point of time?
Sure. So that's basically my true story. Some people find it crazy, some people find it amazed, maybe, but that's the story which landed me upon in this DevOps domain, right? Or where I started following my DevOps practices, right? So it was back in my previous organization where me and my colleague was discussing about that how these platforms, these e-commerce platforms, or let's say your digital payment platforms, right? These applications, how they are hosting these many components in a single application, right? And where did this made into my mind that how they are serving, how they are setting up the whole infrastructure in a single pane, right? You are also able to book your tickets for your movies, you are able to recharge your mobile phones, you are giving the payment for your recharges, right? Your platforms, TV platforms, right? So all of that, and that's when I landed upon that, yeah, we have a concept of microservices where we schedule our workload on containers, right? And when we talk about that, how we can orchestrate these workloads, right? And that's where an orchestration platform came into a picture, right? And that's how we landed that Kubernetes is one of the platform which helps you to orchestrate your containerized workloads at a very large scale and a large pain, right? So that's how I get introduced to Kubernetes.
Yeah, to me, like when I started learning about Kubernetes, I was like, as a kid, like I didn't know anything about the Kubernetes. Everybody told it's Bog and Omega combined together. That's the DNA that goes in the Kubernetes, right? Those two products from Google, things like that. Yeah, I think let's get it started. This is a complete hands-on session. So he's an ex-Calidra person, so he will be not showing you the coding slides like me, but he will be doing something cool. So hopefully you guys learn a lot. Yeah, we can get it started.
Thanks, Rushas. Cool.
Sure.
Let me share my screen, and once it's visible, please let me know.
Sure. It's visible to us.
Great. I would be saying a sorry to the folks that you won't be finding any colorful PPTs to go walk through with. I am a Scally person, would be drawing some sketches which would make you more compatible and with the understanding of those components or concepts which we want to discuss about, right? And if I talk about today's agenda of the session, that would be more focusing on how we tend to move towards our microservices architecture, right? Then how we are managing or using an orchestration platform which is Kubernetes, and finally once we are ready with a containerized workload, and when we know that we have to schedule a workload, which platform can help us in making that generation of our containerized workflow or deploying our containerized workload at a faster pace or at a faster delivery, and that would be your build piper, right? So starting foremost, when I talk about microservices, right? So what is microservice? So microservice, you can say, is an application architecture where each of your application function has its own service, right? And basically those services communicate with each other via APIs. Or even if I talk in more simpler terms, that your microservices architecture, what you do is that microservices allow you to you break down your large application into smaller independent components, right? Where each just give me a minute. Cool. I hope my screen is visible, right?
Yeah, your screen is visible. Yeah.
Cool. Where your application basically helps you help where you are breaking your components, your larger application, into these smaller components, right? And which basically helps you where you can have a part, or that each component is serving you a realm of their responsibility, right? And what could be better than containers to deploy a microservices workload, right? As you know, because what container says is that you should focus more on developing your application, right? On developing your services without worrying about their dependencies, right? And to better understand about the microservices, I would say that we should compare it with monolithic first, right? And when I talk about monolith, so what does monolith means, right? Monolith means basically your server side systems which are based on single application, right? Let's take an example of a Java application, right? When you talk about a Java application, what you do is you build that Java application as a single unit, and you deploy them on your production grade servers or on your application server as a single unit, right? For an example, let's take it as a example of a ticketing company, right? Which we discussed in the earlier itself, that you have a platform which is providing you tickets for your shows, for your movie shows, for your fests, for your sports events, such like that, right? And if I talk about the architecture of that application, what it could be, a general architecture, probably that application would be consisting of a UI, right? If I talk about definitely about all those your tickets, it would be consisting of an inventory as well, right? Then probably you might have some of your recommendations as well from that application, which is coming as per your user input, what all searches you are looking for, right? Then you might have your cart as a service, right? And you can say definitely your payment option, right? Where you would be serving your application, or from where you would be transacting your tickets, right? And lastly, we can say that we can have a reporting channel as well, right, with our application. But in monolithic, you can see that this is a whole bunch of application or acting as a single unit, which would be getting deployed onto your application servers, right, or onto your production grade setup. But what were the challenges which we are facing, right, while dealing with this monolithic kind of architecture, right? So if I talk about the very first big challenge was the high dependability, right? Because these whole services were, each and every service were highly dependent on each other. Let's say the shared library, right? For this Java application, you are using a shared library which is working for each and every component of your application. And let's say whenever you want to configure it or reconfigure it as per your requirement, then you have to make sure that it shouldn't affect your other components of your application, right? That could be one of the big challenge. If I talk about another challenges, let's say language flexibility, right? So let's say your application is growing in the market, and as per your user input, they are asking to introduce some no new features for your application, right? To introduce new features, to bring more capabilities into your application, what you want is you would be writing that feature, you would be developing that feature, and right. And when I talk about this monolith, then you are restricted, that because this is a Java bunch of Java application, you have to be restricted and have to write your capability of your new feature into Java language, right? So that could be the second challenge. Third can be, let's say whenever a new release of your product is coming, right, of your application, then probably you might have seen in the legacy operations, what people generally follows, that on the Friday night they would have shut down their production grade setup, right? And they are upgrading their releases, right? And probably in whole throughout their weekend, they are following or facing or bringing their application up so that the application would be up and running when the week start, right, when the new week start. So these many challenges which we were facing while dealing with the monolithic architecture, right, even at the scale. So when you want to scale your application, right, so at the scaling purpose as well, when let's say your traffic arises on your weekends, right, there are maximum number of tickets which has to be booked out. But let's say when you are scaling your this whole piece of application, and that is taking a lot of time, right, scaling this whole bunch of application could take time. And let's say, what if the duration which you took to scale your application at that specific time, your peak or your traffic on your application or on your website got subsided, right? So in that case, what would be the use of that extra server or that extra scalability of your application, right? Basically that would land you in making losses for your business, right? So these all were the challenges which we were facing while dealing with the monolithic kind of architecture. And that's what landed people or the organizations or the IT ecosystem to move towards the microservice architecture, right? All these challenges which we were facing here, we accomplished them over there, right? So in if I talk about the microservice way, so basically it was your monolith, right? And when I talk about your microservices, right, we talked about that each and every application would be breakdown in its function, and which would be acting as a single service or a solely service, right? So basically here your application would be loosely coupled, right? So you can say your UI would be one of its service, then you have your inventory, right, you have your your recommendations, right, you can have your cart as well, then you have your payment, right? So these all huge bunch of application got segregated into smaller components, smaller chunks, right? And basically these applications are communicating via APIs with each other, right? So that's how your microservices workload works, right? And when we talk about these challenges which we are facing in the monolith one, and we accomplish them in the microservices, then you can say that, let's say, because these whole each and every component of that application is loosely coupled and are independent of each other, then you can say easily that there would be the first challenge which you accomplish can be your language flexibility, right? So now each and every resource team which are working on that specific feature can be flexible in choosing their language of their own preference, right? And they can work upon it. They can iterate their DevOps pipeline into their CI/CD setup, right? Where they would be committing their code. They might introduce their code quality, their static code analysis, or their security checks, and probably would be generating an artifact out of it, and then moving with their CD pipelines, right? Basically, that all works with your DevOps pipeline, right? So that challenge got accomplished over there, right? Then when we talk about the failing of our application, let's say at a peak hour somehow your recommendation didn't work, right? But you are aware that because I am following a microservice architecture, I am pretty sure that my other components of my application would be working fine, right? So that was the one challenge we accomplished. And even when I talk about the scaling of my application, right, or scaling of my application, so when we were saying that we want to scale a payment service, right, my traffic is increasing, so now easily you can scale your containers of your payment service, right? You can easily do that as well. Majorly all the challenges got accomplished while dealing with a microservices way or microservice architecture, right? And that's how we create a difference, or we see the differences between a microservice architecture or a monolithic architecture, right? So till this point of time, we are pretty much clear that we are approaching with a microservice way, right? We would be containerizing our workflow or workload, right? And now what I want a orchestration platform which would basically help me to orchestrate my resources, right, to maintain their network, to maintain their deployments, their balancing, load balancing, you can say the deployment strategies, each and everything, right? And for that, what we did, we landed upon an orchestration platform that is your Kubernetes, right? So instead of going deep dive into the Kubernetes architecture or discussing about each and every component of Kubernetes, what I'll do is I'll take you in a cool exercise. Basically, that would be talking about the basics of Kubernetes, but in perspective of that, how does a pod get scheduled onto your Kubernetes workload, right? And that would be a pretty cool exercise for you guys, right? So whenever I talk about a Kubernetes cluster, right? So or Kubernetes workload, right? Or container workload. And when I'm using Kubernetes as an orchestration platform, what we generally see, what we use is in the terms of Kubernetes cluster, we see two main nodes, right? And what are those two types of nodes? So one would be your basically your control node, right? Or you can say it as a control plane, right? For our example, as of now, I'll just go with a single control plane, right? A single, but when I talk about a production grade setup, basically over there you have at least three machines set up for your control plane, right? To maintain your high availability of your system, right? Or of your Kubernetes cluster. And the other nodes are your worker nodes, right? So, or you can say your data nodes, right? So let's start with scheduling a workload, right? That I want to schedule my very first workload or my containerized workload onto my Kubernetes cluster. Let's say, let's say I'm the one who would be scheduling a containerized workload, right? I am the user, probably using a kubectl command, right? Which would help me out to schedule my workload, right? I would be using a kubectl for that to schedule my workload. Let's say I would be applying my manifest file, any of my manifest file, right? And what's the first component which becomes the priority, or which you can say the main component of your Kubernetes cluster, which helps you to communicate with it, and that becomes your Kube API server, right? So Kube API server, you can say that it is the main component, or you can say the main heart of the Kubernetes cluster system, which manages or which take cares of your whole Kubernetes cluster or your workloads, right? So Kube API server is the ones, or this you can say this is the front end of your Kubernetes cluster, right? So once you assign a command, once you calls your request to schedule a workload, it directly goes to your Kube API server, right? After that, what it does is it's, let's say what I want is I want to schedule any of my microservice, saying that two pods of this should get run on it, right? So what it does is, right, it takes the basically the desired state from you, right, and makes a successful write in the HCD, right? So basically your second main component of your control plane becomes your HCD, right? And what is HCD? HCD is basically a data key value data store which is distributed across your cluster, right? Which basically maintains or records all of the data regarding your Kubernetes cluster, the configuration, the state of your cluster, your worker nodes, each and everything, whatever workloads you are scheduling upon your Kubernetes cluster, each and everything is getting maintained under this HCD, right? So once what happens, once the write of your request, the user request gets succeeded, once the write is successful, it responds back to the Kube API server, and you get back the response that your workload has been scheduled, right? But till now what we see that our workload hasn't been scheduled, right? But as far Kubernetes is concerned, your workload has been scheduled or it gonna be scheduled, right? So you get the response that your manifest has been applied or your resources has been created, right? Now your third components comes when we talk about the control plane, that is your scheduler, right? Your schedule manager, Kube schedule manager, right? So what it does is the, the main work or the agenda of this piece, this component of Kubernetes cluster control plane is to check that whatever workload which I am receiving from the users end has to be scheduled on which specific worker node, right? So basically it checks that, checking out all the checklists which user have defined, what all factors which has to be ticked out to schedule that specific workload on those worker nodes. Your scheduler manages that, right? And even after that, what scheduler manager is doing is that scheduler manager is keep on pinging your API server at a regular interval. Let's say usually 5 seconds, right? It does keep on pinging API server that, hey Cube API, do we have any workload to be scheduled onto our worker nodes? So let's say it pinged at the initial phase, right? So after 5 seconds, it ping back again your API server, and API server says, no, right now we don't have any of the workload to be scheduled on, right? Again, after 5 seconds, your scheduler manager went and ask API server, do we have any workload to be scheduled on? And now Cube API server says, yes, Deepak has asked to schedule some of the workload onto our worker nodes or onto our Kubernetes cluster, and let's do it, right? So now taking a pause from a control plane side, now we'll move towards the the worker node side, right? So what all different components we have in our worker nodes, right? So we have basically three main components. That one is your kubelet, right? If I talk about kubelet is the main component of your worker node, which basically helps you to create and destroy your workloads onto those specific nodes. And even it's the first channel which is getting communicated with your control plane or to your API server, giving the health checks of these worker nodes back to the API server, that these worker nodes are healthy or they are ready to schedule workloads on them, right? Each and everything, right? So this kubelet is performing on behalf of you, right? The second component we say is your container runtime engine, right? So in the past we generally use Docker as your container runtime engine, right? And because it is compliant to your CRI, right, your container runtime initiative, right? And whatever a platform which is compliant to your CRI, you can use that container runtime engine as well, right? And your third component becomes your, so your kubelet is present on your all the worker nodes, similarly your CRI as well, right? And your third component becomes your kube proxy. I won't say that kube proxy is the one which would be helping you out to schedule your workloads, but if I remiss them, then it would make no sense when we are talking about the architecture of Kubernetes, right? So kube proxy, you can say that when you want to commute between these worker nodes, right? So what would be the component helping you to do that? So that would be your kube proxy, basically, right? Now coming back to our control plane component, that was our schedule manager, right? So what we discussed, that it's keep on pinging at a regular interval to the API server, that do we have any workload to be scheduled on, right? So once scheduler manager gets to know, uh, checking out all the factors, all the points taken into the consideration, that my workload has to be this specific to be scheduled on. Once your scheduler manager decides that, let's say my worker node 2 is ready to accept or to set up that workload, right? So what does scheduler manager do? Scheduler manager sends that response back to the Cube API server, right? And do you think that now my workload is ready to get scheduled on? No. So what, after that, what Cube API server does is, Cube API server sends this request back to the HCD, that the workload which Deepak has asked to schedule on can be scheduled on to the worker node 2, right? Now it is ready to schedule our workload. No. So now what it happened, that now HCD has got that write successful, and after that HCD again ping back to the Cube API server, and now your Cube API server sends that request to the specific kubelet of that worker node, that hey, we have got the workload to be scheduled on, and this you can schedule, right? And this was the workload which Deepak asked for to schedule, right? And now you can see our pod got scheduled, which with talking with each and every component of Kubernetes architecture, using each and every component of a Kubernetes architecture, right? Foremost, and additionally, the last component which we mostly talk about while dealing with a Kubernetes architecture, that is your controller manager, right? Your where you have your controllers, right? You in this controller you have multiple controllers. You have your deployment controllers, your replication controllers, and many more, right? So their work is also the same, that they keep on pinging the API server and manages and checks whether the desired state which is coming from the user side, or you would say that actual state which is present inside my Kubernetes cluster, is it matching the desired state which is being asked by the user? So that is what controllers does, right? So let's say if somehow something happened to my pod and my pod crashed out, right? So in that case, who would be the one to rebring my pod up, right, into my Kubernetes cluster? So there your controller managers get triggers, right? Or specifically if I talk about, then it would be a replication controller, right? And that replication controller sends that request back to your Cube API server, and your workload get rescheduled onto that workload. I hope till this point of time is pretty much clear to everyone, right?
Yeah, everybody's enjoying it. Like everybody is also making sure that they also get ready for the hands-on as well. So yeah, we can go ahead.
Great, great. But till this point of time, you might have seen that there are huge lot of components which we are dealing with, right? And when we are talking about a whole Kubernetes cluster, you can see that how many components we have, right? And if I talk about, when we are talking about the latest practices which is followed in nowadays, that is to deliver at a faster pace when market is growing at a very high rate, right? You are bringing new features, you are introducing your applications by each and every day. So in the, you have to make sure that your customers are satisfied, right? You are making your deliveries at a faster rate. So to do that, so what practice says is that you should more focus on developing your application, or you can say you're developing your feature or introducing them into the market, right? Instead of going into the integrity of creation or provisioning of your servers or managing your servers, right? So these many things, so that's what people landed upon using Kubernetes as a managed service, right? Not getting into the integrity of setting up these Kubernetes cluster or each and every component. And when I was talking about a production grade setup, right? So definitely in a production grade setup, you won't be having only a single control plane, or you won't be having only a single worker node or a two of your worker nodes. You would be having many more, right? So that's what landed upon people to use managed service of Kubernetes, right? And when I talk about that, you can just consider it in a manner that you are handing off your Kubernetes cluster to any of your managed service provider, right? And it can feel like similar that you are sending your kid to your college, right? It is scary at a first place, but eventually there is a lot less work to do, right? Similarly, that we do when we use the options of managed Kubernetes, right? Which you can say the very big three public cloud providers, that would be your AWS, right? Your Google Cloud, you have your Microsoft Azure, right? Which have made a huge strides over the past few years, right? Which are helping out customers to run their or to orchestrate their containerized workload on their managed Kubernetes platform. So you don't have to get into the integrity of setting up that Kubernetes cluster. You just directly go to their consoles. You set up either by using the console, either by using the CLIs, or by any of the infrastructure as a code tool. Let's say your Terraform, right? So you can provision your clusters over there, and you can start just deploying your application onto that, right? You don't have to get into integrity of setting in each and every component, right? And what could be the benefits while using this managed service of Kubernetes? You don't firstly your management overburden, right? It's get limited, right? Or it's get tackled out. You don't have to be into that. How would I set up my control planes? How would I make them highly available, right? What about my HCD? Will it be distributed across my cluster? How would I maintain the state of that? Will the data would be persistent or not, right? So each and everything got managed by your service providers, right? Your cloud service providers, right? Let's say about their upgrades, right? Their patches. In today's time, you generally see that Kubernetes is also your, which is managed by your CNCF, right? Your Kubernetes is managed under CNCF, which are releasing their um, new releases of their APIs, right? Where you bring multiple changes, right? So the upgrades of your each and every component of your Kubernetes cluster, your Cubelet, your kube proxy, how would I gonna manage that? Again, those tasks are also getting um, overridden by your service providers, right? They are doing for you, right? So each and everything, these kinds of things are getting managed by your service providers or your cloud providers. What you mainly have to focus is on developing your application and deploying your application, right? I hope makes sense. So
Yes.
till this point of time, when we have discussed all about microservices, microservice architecture, what would be the orchestration platform which I'll be using, right? That is Kubernetes to orchestrate my container workload. Lastly, what I need a platform, right? I need a platform where I can build my container workload, where I can with the platform I can deploy my container workload onto those clusters, right? Very easily, very with the very minimal effort, right? Manage in such a manner so that any guy, not specifically your DevOps guy or your project admin, should be aware of that feature or that expertise. Even your developers, even your QA guys, right? They can manage their build of their applications or their deployment of their application on a lower grade environments. For that, we need a platform. And that's where we say that whenever it's about microservices delivery, it's always BuildPiper, right? So if I talk about BuildPiper is basically in-house build product from the Opsy solutions, coming from the Opsy labs. And if I talk about my personal experience or even the client experience, right, you can see that how many customers right now we are serving in the market, right? Their experiences says that they have made their deliveries at a very faster pace, right? They are more focusing right now on developing their application, developing their features. BuildPiper is somehow managing each and everything. Be it's their CI, be it's their CD, right? Their pipelines, their approvals, each and everything behind the scene. BuildPiper is maintaining and managing each and everything for you, right? And even if you guys want to try out, right, either you can have we do host a try server, right, demo server, where you can try out our BuildPiper as a product, where you can onboard your microservice and you can play around, and even you can book a demo as well, right? So that's what we gonna discuss about today, right? That how we can manage the CI and the CD part of any of our microservice, right, with the help of BuildPiper as a tool, right? So if I talk about BuildPiper ends up in two different areas. That one would be your project admin, and one would be your end user or a client usage section, right? So you can say that when I talk about the project admin section, it would be basically favoring towards your onboarding of clusters, right? Onboarding of your registries, where you would be storing your artifacts, like these kinds of things, which should be managed by your project admins or your DevOps guys, right? The second platform, that is the section which you are right now seeing on your screens, that is your user end section, right? Where you get a holistic view that right now in my infrastructure, what all I have, how many clusters are there present, right? How many applications does I have, how many services do I have, right? And when I was talking about microservices, right, so we did mention that your application would on its own would be acting as a single service or a solely service, right? That is the loosely coupled nature of microservices, right? Then similarly, how many pipelines does you have? So all a holistic pane view is coming on a single dashboard, which can be visible by any of your guy, be it your developer, be it your QA, or your DevOps guy, right? So as of now, because this is the very first session regarding a BuildPiper, we won't be deep diving into multiple features what BuildPiper support, but we'll start with the very minimal, the very basic. That would be your CI/CD portion, right? Where how can I configure my build proportions of my microservice, or how can I configure my deploy section, right, for a microservice. In upcoming sessions or in our future sessions, we would be covering each and every functionality of BuildPiper as well, right? So over here in the home dashboard right now, what you can see is that what we do is we segregate, or we do a logical grouping of our application. Let's say, for an example, definitely in an infrastructure you would be having some of your front end applications, right? Some would be your backend applications, right? And those applications again would be consisting of your multiple microservices, right? Those services, small services, right? Similarly for your backend as well. So similarly in BuildPiper, you can see that what we do is, or what we go with the approach of logical segregation or logical grouping of our applications. So right now, what you can see is that for this application, I have named it as S3HA, right? Either you can give it as front end, you could have a second pane, which would be defining your backend application, which would be consisting of multiple services, right? So for this specific application, what I have two different services, right? For that, I am having two different environments as well, right? Then I have two pipelines, and what infrastructure I have my EKS cluster behind the scene which is running, right? So we'll start with configuring our very own first microservice, right? So whenever you want to create or onboard a new microservice onto a BuildPiper platform, you get this dashboard section and you go to the option of add a service, right? You click on it, you name your application. Let's say I want to name it as demo application, right? And you save and continue, right? Moving further, you it asks for you to what environment do you want to build your application for, or you want to deploy your application for. Or when we talk about logical segregations of your environments in terms of Kubernetes, basically that is your namespaces, right? What we are defining your environments on the basis of namespaces. So let's say I want to deploy my artifact onto a dev namespace, right? That's what I'm using, right? And whosoever can have the access to this application, that I am defining on the basis of roles, right? So basically these roles or these groups would be getting associated with your multiple users in your organization. So what you do is you create user and you assign these roles to that those specific users, right? So right now I'm giving the access to each and every group of ours, right? And once done that, your service is being created, right? But till now what we saw, just we have introduced a service into our dashboard or into our application. But what about now the build details, right? The deploy details, right? So we'll go one by one. The option comes that when you want to configure your build details, right? So over here you can directly see that now you define wherever you are keeping your code as a version code, right? Where are you maintaining the history of your code? So definitely it will be a version control system, right? So let's say if I want to have my one of our application, right? Basically it's a Java based application, right? So taking this as an example, I define my repository URL, right? Then as of now it's basically a public repository, so we don't have to configure any of the repo credentials. But let's say definitely in an organization you would be having your private repository. So you what you can do is you can add your credentials, and these credentials could be of type password, your SSH keys, your token, your access tokens. Or let's say you have your let's say your repository is hosted any of the cloud providers, let's say AWS code repository, right? Code commit, then you can provide your access keys and secret access key details as well, right? So right now it's as a public repository we have, let's say I want to build with my dev branch, right? And in the build context what I define is generally where your Docker file, right, which would help you to generate that artifact or to generate your containerized image, right? So in the context, I over here as well I have my Docker file present, right, which would be helping me out to build my application. Right now moving forward you can see the image name, right? So basically this image name or is the repository name, you can say, which is present inside your registry. Let's say if you have ECR as a registry, right, your Elastic Container Registry. So what repository name you created for, you define that repository name, and once the artifact or once the image got built out of here would get published into that specific repository, right? So that is the definition you define in your image name. Now you can see the advanced configuration as well, right? So you might have seen that today's time people are moving towards the cost optimization way, right? So whenever people talk about cloud native applications or technologies, they move or they migrate their workloads onto the cloud, but they get hesitate while dealing with their bills, right? Because they are not much aware about that how my bill is getting considered with these many resources to do that. So in similar pattern, AWS recently introduced the graviton processes, right? So those graviton processes basically helps you with the better performance and with lesser cost, right? But the main catch for those graviton processes is that when you are scheduling your containers workload, then your image should be of ARM template, right? Basically that is your multi architecture support, so your image should support the ARM architecture as well, right? ARM 64. So BuildPiper does that as well behind the scene. So you just define that on which architecture you want to build your image for, be it your AMD processors, be it your ARM processors, right? You can define or you can select that specific processor and you can proceed with that, and your BuildPiper would help you out to build that specific architecture image, right? So in the advanced configuration you can do that as well. Next you have your languages as well, right? So which language is your application built on, right? So let's say you can select that and it would be helping you out to generate your artifact. Let's say generally what people do is that in their Docker file, following the best practices, they can define the multi-staging concept. But let's say if they want to generate their artifact on their own and probably then they want to push it inside their Docker image, so with the help of language selection they can do that as well from BuildPiper, right? Let's say if they have their CI in place, right, and they want to publish the reports of their static code analysis, their code qualities, right? So they can do that as well. They select the option of CI report to Sonar, they select define the project key, and that's how your CI reports gets published, right? Continuing with that, if you want to introduce some of the environment variables, right, your environment variables for your image, right, the raw environment variables which you define, so you can do that as well, right? Coming forward, if you have your pre-hooks or post-hooks, let's say you want to execute some of the scripts behind the scene, or let's say when we were talking about the multi-staging concept, right, you don't want to go with that approach. What you want is you want to build your artifact from your local machine itself, and that's how you want to move your artifact into your Docker image, right? So probably if I talk about a Java based application, what could be your pre-hook, right? It would be generating your artifact. Let's say Maven was used as a build tool, then Maven clean install or Maven clean package could be the command which would be helping you out to generate your artifact out of it. And that would be, post that you can add that. And in this pre-hook sections or in the post-hook sections, you would see that we are providing you that three supports, that either via command line, right? So you can directly put your command line as well, that which pre-hook command you want to execute, right? Then if you have a file to upload, your script file or your batch process job script file which you want to upload, you can do that as well. And if your details are present in your version control system, then you can provide that as well, right? So these are the options which you can opt for. And once you submit that, that's pretty easy was to build or to configure your build details of your microservice, right? And once your build details have been configured, you click on the icon of build, right? You click on it, right? And you trigger your build. And once you trigger your build, in the build section itself, you can check the logs which are getting generated, right? So what's the the most beautiful nature of a BuildPiper is that it, what each and every step which is getting executed while you are performing your build, right, or your CI sections, so logs would be getting generated for it, right? So let's say if I go to my existing, any of my existing service, let's say for this, right? And in the similar section of our icons, we have the history section as well, right? So over here you can get the all the insights regarding the previous builds or your previous deploy, right? Whatever you want. So let's say if I want to check the details of my third build, right? So over here you can check the logs regarding the application, right? So what it did first, it cloned a repository, right? Then if my system had so many of the pre-hooks defined, then those pre-hooks would have been executed. Then what it is doing, it is building the Docker image, right? Once my Docker image got built, it pushed the Docker image to the specific registry or repository, whichever you have defined. And post that, if you have any post hooks defined, right? So all those specific logs are getting. So whenever if something fails, right? So it would be pretty much clear to you guys that at which stage my CI got failed, right? Instead of getting the whole logs at a single page, you would have to find that at which stage my CI pipeline got failed. But over here you can directly have a look that on which stage my build got failed, right? So that's the most beauty of it, right? So this was how you can configure your build details, right? Now moving forward with the deploy details, right? So let's say my artifact is generated, my containerized image is generated and has been pushed to your repository, right? Now what about my deploy details? Now you want to deploy your workload, right? So over here itself you get two different ways, right? One is your UI way or one is your custom manifest way, right? So let's say if you have your custom manifests to be uploaded, right? So you can opt with that. Even in that options, if you have your manifest files to upload, if they are present in any of your version control system, or even if you have your Helm templates ready, right? So you can opt any of those as per your requirement, right? So this is one of the way. And when you are using as a product, it does supports you the UI way as well, right? That is the BuildPiper UI way, right? You don't have to get into the integrities of writing those manifest files on your own, those whole Kubernetes manifest file, be it for your deployments, be it for your service, or be it for your ingress manifest file as well, right? So each and everything can be maintained and managed by your BuildPiper. So over here itself, you can see that the service name got generated for your application, right? We named it our microservice as demo application. So demo application right now, we are going with the dev environment. So dev. Similarly, the image name, this is the specific repository registry name, which is coming up automatically over here, which your image got published into, right? Then your deployment name, how many replica counts you want to define, let's say 2 or 3, right? And when you have your ingress manifest files, right? So is your application private? When I talk about private, probably it won't be creating an ingress file, right? It would be just landing upon or ending upon your deployments or your service. That would be your cluster IP. Basically, that means your application only has to be accessed internally via other microservices, right? Let's say if it is protected, let's say for an example, if you are hosting you're monitoring the stack inside your Kubernetes cluster, right? Let's say when you want to access your Grafana dashboard, so in that case you would be creating your protected ingress controllers and you would be opting for that. And let's say if you want to expose your application publicly, then you would be proceeding with the public one, right? This is the UI way. Even for that ingress manifest, if you have your ingress manifest files written, right? You can opt with that way as well. You can directly upload your file, or even you can upload it via Git as well, right? So right now I'll just keep it as private, right? On which port my application is running, I define that, right? Moving further, this is something which is specific to your Kubernetes terminologies, where you define your request or your limits for your containers, right? So your request memory quota or your limit, right? So your memory quota for your requests for your memory quota, your request for your CPU, and similarly limit as well for both your memory and CPU, right? So let's say I'll keep it as this, right? And define that. I move with the configurations and secrets. Definitely, when you are talking about a production grade setup, your application would be, you're requiring some of the properties which you have to bind, or with the help of configs, or with the help of secrets, or it can be volumes to make your data persistent. So all those things can be defined directly from the UI itself. Let's say if you have your name config maps created in your namespaces, specific namespaces, what you can do is you can select these options, right? Your each and every config map which is present inside that namespace would be getting reflecting out here. You can opt for that, and you can mount at a specific path wherever you want, right? So you can do that as well. So with for your config maps, for your secrets, similarly for your PVCs, if you have defined, right, your PVC's scope is limited to your namespace, right? So you can do that. Even if you have custom entry point, you can define that as well, right? Then you continue, you can define your raw environment key value pairs for your containers. Even there is a method in which you can select your config map or your secrets as a key reference, right? So you can do that as well. Select your config map, you define your service key and the value for that, right? Even as a build environment variable. Then coming towards your selector portions, right, where you have your node affinities, your service affinities to be defined, you can do that as well, right? So let's say whenever you want to schedule your specific workloads, right, let's say if your workload requires higher resource of utilization, and you have a mixture of worker nodes into your Kubernetes cluster, you have higher specifications of computes, you have lower specifications of computes, and you want to specifically define that this microservice should get scheduled onto a higher specification of worker node, then you can do that with the help of your labels or annotations which works behind, right? So you can define your labels, annotations which you want to work with, and you can directly opt with the node affinity option as well, right? Moving further, you have your deployment strategy, right? That is the default strategy which Kubernetes follows, that is your rolling strategy. So again, for that, your BuildPiper UI gives you the option that how do you want to configure, right? What the max surge you want to keep, what's the max unavailable conditions, right, which you want to keep, the revision history limit, each and everything. Even it says that if your application has your shallow health checks paths, right, you can define them as well to basically define the initial delay for to bring your application ready, right? So your liveliness checks and your readiness checks as well. And it supports both your URL, your HTTP or TCP type, or even if you have command to be get executed, right? So you can opt for both. Finally, once you are done with that, you define your labels or annotations if you have for your deployment, or if you have any of the hooks to be defined, right? And once you do that, your deploy details are configured, right? And how easy was that, right? You didn't have to get into the integrity of your writing those manifest files, right? Nothing. You just configured with the help of a UI. You provided those details, right? What name you want to keep for your deployment, your service, where would be the image getting picked up from, right? Each and everything. And once you do that, you go to the second icon, that is your deploy icon, right? And you from directly, so let's say probably the application might be still in the building phase. Let's say my already existing microservice, right? So similarly, I click on the deploy details, right? Automatically the tags which are present in my registry or in my repository would be reflecting out over here, right? So whichever tag I want to select for my deployment process, I can select that, right? And I can click on my deploy section. And when I click on it, so the most beauty comes is the analytics portion of my deployment, right, of a BuildPiper. So you can see that how my deployment or how my rollout is happening for my newer release, right? So what I did, I am upgrading from the artifact of my first tag to the artifact of my third tag, right? How my old replica set, you would see that how my old replica set would come into the terminating state once my new replica set comes, or my pods comes into my ready state, right? So this is the analytics dashboard view where you can have a look at how my rollout is happening for my application or for my microservice, right? Not only with these details, you can specifically for the pod status details, you can see that your conditions, right? So if I refresh, you can see that your deployment got succeeded, right? Your artifact got succeeded. You can find out the details as well. Your the artifact with the third tag got deployed onto your Kubernetes cluster, right? If you want to check the YAMLs as well, that what all different manifest files got applied onto my system, you can do that, right? So these are the manifest files which would be applied. Similarly, going back to the pod status, in pod status, you can see that this is the replica set which got created, right? The new replica set, the conditions coming, right? Events which got generated. This is basically your pod events which got generated, right? Successfully assigned the image, right? How many containers has been spinned up inside this pod, right? And even the logs of your containers, right? Even the log of your pods, whatever logs which you are printing out in your standard output would be getting reflected over here. And these are the real time logs, right? So whatever your pods is giving out in the standard output manner, they would be getting reflected out over here itself, right? And you can see, right, that the applied manifest files which got applied onto your Kubernetes cluster, your deployment manifest file. And even if I want to check from the UI itself, right? So once my deployment got succeeded, even you can check in the details itself, right? You did configure your build details, you did configure your deploy details. You can come to your generated manifest file option, right? And over here you can check that what all different manifest files got applied, right? I have my deployment file, I have my service manifest file got created, right? Even you can see the ingress option which I created, and the hpa.yaml as well. And when I talk about this hpa, right, so how we can land upon the hpa or the scaling part in Kubernetes, right? So once my application is being set up, I am definitely your replicas or your state of your pods can be maintained and managed by your replica set. But what about when my application has to handle that workload and has to be scaled when traffic is rising? So in that case, your scaling capabilities comes into the picture, right? And that is something which also can be managed by your BuildPiper UI, right? You can strict direct forwardly, you can define your HPAs for your specific microservice, right? So in this other deployment info, you can have that you have your HPA to be defined. You click on the edit section, you give a name to your HPA, right? What should be the minimum count for my microservice, what should be the maximum count, and what is the average utilization target you want to define, either for your CPU quota or for your memory quota, right? You define that, you save that, and you deploy it, right? So you can deploy that as well. And even the most beauty part, right, which says your add time based HPA. Let's take an example of the e-commerce website, right? So we are pretty much sure that traffic would be coming on the weekends, or let's say on the sale time, right? So what we can do is we can define the specific time based HPA as well, right? You can name it whatever minimum, let's say I want to name is time based HPA, right? Let's say I want to keep the minimum as 10, I want to keep the maximum as 20, right? Threshold to be 49, 50, whatever. It's all totally up to you, right? On what selective days you want to keep it. Let's say I want to keep it on my Friday and Saturdays, right? But what duration you want to keep. You can define the start time, you can define the duration, and you can save it, right? So whatever you are defining. And once you deploy that at that specific interval, it would be keeping this HPA in place. And once that duration ended, automatically it's shift back to your default HPA, right? And that's the beauty of BuildPiper, how you can basically integrate or follow your CI and CD portions for your microservice and make your delivery at a faster pace. I hope this seems to be a beauty, right? How easily you are able to manage your containerized workload with the help of BuildPiper Azure CI/CD platform. Great, great. And on this beautiful note, I would like to end and would like to have the feedback from you guys that how did you find, and not on this platform, I would also say that this is not our end of our session, or let's say not end about this build piper. We would be bringing multiple more shows in which we will be talking about more functionalities and features of build piper, that how it can be leveraged in your organizations for maintaining and managing your containerized workloads or your microservices delivery. Thank you.
Thank you so much, Deepak. Thank you so much for such an amazing introduction. Writing YAML files is one of the biggest challenges that any DevOps team has today, because there is a chance that you are compromising on security, because
Yeah.
we are giving you a SaaS playground, by the way, but it doesn't mean that it's completely a SaaS product. The BuildPiper as an entire software stack stays in your system. That means your
Mhm.
infrastructure. And guess what? It's just not just shift right, it's also guard right at the end of the day. So you're actually keeping the governance and the policy intact, and you're not making sure that any sort of an security, what do you call, the vulnerability is being hit you at any given point of time. I think one of the
Yeah.
greatest ways to explore what is Kubernetes and things like that, it's BuildPiper. I think
Yeah.
writing YAML files is a big task, and I think last session was all about the YAML files. Today it's all about automating the same old YAML files to be generated, and I think that
Solid.
was great. Yeah, I think,
Great.
to be very frank with you, there are a lot of case studies that we have. Please do go through the case studies, because these case studies have been one of the best in the best. Like, the numbers speak there. The number of pipelines, the DevSecOps practices that we have bought in using BuildPiper is something humongous. And I think there's a lot of release notes from our team. So do check that out, as well as we also have multiple integration with respect to security, observability, and logging. So you can check out the documentation and reach back to us. If you have anything more to be told to us, like if you want any new feature from the Build Piper, we are here for you. Thank you so much. And by the
Great.
way, thank you so much, Deepak, for this amazing show.
Thank you. Thank you, guys. Have a great day. Have a great weekend.
Sure. And if you wanna book a demo, don't worry. Just reach out to us at connect@buildpepper.io, and we will be there for you, helping your team transform to be a Kubernetes guys out there. So thank you so much, Deepak. Thank you so much, everybody. We are signing
Great.
off now.